Question 5a. In the diagram, Q, x0, y0 is a point on the unit circle x squared plus y squared equals 1 at an angle theta from the positive x-axis, where theta is greater than negative pi over 2 and less than pi over 2. The line through n, 0, 1, and Q intersects the line y equals negative 1 at P. The points T, 0, y0, and S, 0, negative 1 are on the y-axis. Part 1. Use the fact that triangle TQN and triangle SPN are similar to show that SP equals 2 cos theta over 1 minus sin theta. In triangle OQT, angle OQT is equal to theta as they are alternate angles on parallel lines, where QT is parallel to the x-axis. Also note that angle OTQ is a right angle, which makes triangle OQT a right angle triangle, and this means that right angle trigonometry may be applied to find the lengths of QT and OT in terms of theta. Also note that OQ and ON are both 1 unit in length as they are radii of the unit circle. So I've started this by noting down what I've just said. Angle OQT is equal to theta, and here's the reason. And triangle OQT is right angled with OQ is equal to 1. Now applying right angle trigonometry, QT over OQ is equal to cos theta. Now OQ is equal to 1, hence QT is equal to cos theta. OT over OQ is equal to sin theta, and OQ is equal to 1, hence OT is equal to sin theta. Now NT is equal to ON minus OT, hence NT is equal to 1 minus sin theta. Now NS is equal to 2, since that's the diameter of the unit circle. Now applying the property of similar triangles, NT over NS is equal to QT over SP, where NT is equal to 1 minus sin theta and NS is equal to 2, and QT is equal to cos theta and SP is of course itself SP. So rearranging this equation to make SP the subject of the formula, so swapping both sides around and inverting both fractions, we have SP over cos theta is equal to 2 over 1 minus sin theta. Therefore, SP is equal to 2 cos theta over 1 minus sin theta as required. Part 2. Show that cos theta over 1 minus sin theta equals sec theta plus tan theta. Starting from the left-hand side, we have left-hand side equals cos theta over 1 minus sin theta. Multiplying the numerator and the denominator by 1 plus sin theta, that gives us left-hand side equals cos theta plus cos theta sin theta over 1 minus sin squared theta. 1 minus sin squared theta is equal to cos squared theta by application of a Pythagorean identity. So left-hand side is equal to cos theta plus cos theta sin theta over cos squared theta. And expressing this fraction as the sum of two fractions with a common denominator of cos squared theta, that equals cos theta over cos squared theta plus cos theta sin theta over cos squared theta. And simplifying these fractions, that equals 1 over cos theta plus sin theta over cos theta, which equals sec theta plus tan theta, which equals the right-hand side as required. Part 3. Show that angle SNP equals theta over 2 plus pi over 4. Angle SNP is equal to angle ONQ. So by determining angle ONQ, we've determined angle SNP. Now OQ and ON are equal in length, since they are radii of the unit circle, which makes triangle ONQ isosceles. This means the base angles are equal. So to determine the size of the base angles, we need to find the value of this angle here, the apex of the isosceles triangle. And this angle here is complementary with theta. So this angle here, NOQ, is equal to pi over 2 minus theta. Noting this down, ON equals OQ, hence triangle ONQ is isosceles, and angle SNP equals angle ONQ equals angle OQN, which are the base angles of the isosceles triangle. Angle QOT, which is the apex of the isosceles triangle, is equal to pi over 2 minus theta. Hence, angle ONQ, which is one of the base angles of the isosceles triangle, is equal to pi minus pi over 2 minus theta in brackets divided by 2, which equals to pi over 2 plus theta divided by 2, which equals to theta over 2 plus pi over 4. Therefore, angle SNP is equal to theta over 2 plus pi over 4 as required. Part 4. Hence or otherwise, show that sec theta plus tan theta equals tan theta over 2 plus pi over 4. In right-angled triangle NSP, side SP is equal to 2 cos theta over 1 minus sine theta, which equals to 2 sec theta plus 2 tan theta. That's from parts 1 and 2. Side NS is equal to 2 units, since NS represents the diameter of the unit circle. And angle SNP is equal to theta over 2 plus pi over 4, and that's from part 3. Putting this all together, we can write SP is equal to 2 cos theta over 1 minus sine theta, which equals to 2 sec theta plus 2 tan theta from parts 1 and 2. In triangle NSP, angle SNP is equal to theta over 2 plus pi over 4, and that's from part 3. Triangle NSP is right angled, with angle NSP is equal to theta over 2. Hence, tan of angle SNP is equal to SP over NS. So that's the opposite over the adjacent. Tan of theta over 2 plus pi over 4 is equal to 2 sec theta plus 2 tan theta over 2. The 2's will cancel. Therefore, sec theta plus tan theta is equal to tan of theta over 2 plus pi over 4 as required. Part 5. Hence or otherwise, solve sec theta plus tan theta equals the square root of 3, where theta is greater than negative pi over 2 and less than pi over 2. From part 4, sec theta plus tan theta is identical to tan of theta over 2 plus pi over 4. So solving sec theta plus tan theta equals the square root of 3 is identical to solving tan of theta over 2 plus pi over 4 is equal to the square root of 3. Taking the inverse tan of both sides, we get theta over 2 plus pi over 4 is equal to negative 2 pi over 3, pi over 3, and 4 pi over 3. Just taking into account the stated domain, which is theta greater than negative pi over 2 and less than pi over 2. So I'm just thinking ahead a little bit here. Subtracting pi over 4 from both sides of the equation, we get theta over 2 is equal to negative 11 pi over 12, pi over 12, or 13 pi over 12. And then multiplying both sides of the equation by 2 to make theta the subject, we get theta is equal to negative 11 pi over 6, pi over 6, or 13 pi over 6. But theta is greater than negative pi over 2 or less than pi over 2. So the only solution that satisfies this domain is pi over 6. So therefore, theta is equal to pi over 6.